Hello students, I am Muhammad Kamran Halil from YouTube channel The Twins Academy. Students, we have already discussed the topic related with the kinematics which we have started earlier. In the first video, you got concept related with the distance, displacement, then acceleration, velocity, the difference between the distance and displacement, all things we have already learned along with some past paper questions. Today in this lesson, I will teach you the graphical method to represent the distance, displacement, speed, velocity and acceleration. So the today topic is particularly related with the graphical portion of the kinematics. In one lesson, I will not able to complete all the paper related portion related with the graphs. So I will make 2 or 3 videos and then after that I will continue to solve the past paper questions. So this channel is run by me and my identical twin Rizwan Halil. So if you want any online classes, so you can contact us on the WhatsApp. The number is in front of you on the screen. So here we go, move towards the topic. So graphs, what is the importance of the graph? The graphs will give you really a very brief idea related with the object movement, because we are discussing the topic related with the kinematics. So in kinematics, we will discuss two different type of graphs. Number one is the distance time graph and number two is the velocity time graph. So graph number one. In graph number one, you can observe that I will make it a little. Okay. So in graph number one, what we are observing that the time is increasing from 0 up till 5, but the distance will remain same. So if you will label the axis, then you will get a straight line which is parallel to x-axis. So for distance time graph, if line is parallel to x-axis, it will certainly show that object is at rest. It is not moving. The best example related with the this situation is that you are on the red light and waiting for the red light to turn into green. So the distance covered already by the speedometer will remain same while the time will pass on. Now the second graph. Second graph, if the graph is a straight line and passing through the origin and make some inclination with the x-axis, then this graph shows that object is moving with the uniform speed. The alternate name of the uniform speed is steady speed, then constant speed. So how can we evaluate this speed? 10 divided by 1 gives you 10, then again 10, 30.3, 10, then again 10, then again 10. So this will be the speed, and we can calculate speed by applying formula distance divided by time. Always remember, distance is represented by symbol s, time is represented by t. So here are two more things related with this, that if the inclination is greater or the graph is more steeper, it means that the gradient will be more steeper. So if we will consider three objects called as A, B and C, so which one will have the greatest speed? Certainly object C will have the greatest speed because its inclination or its gradient will be maximum, and the slower speed belongs to object A. Now how can we calculate the value for the speed from the graph? For that we will use the technique which is called as the gradient. What we will do, we will take 2 points away from each other. First of all, we will write down the coordinate related with the x, 4 and then 40, and for this we will mention it 1 and as a 10. So it is x1 and y1, it is x2 and y2. So in order to calculate the speed from distance time graph, because speed is distance over time, So we will use the formula related with the gradient, which you already know, y2 minus y1 upon x2 minus x1. So then we will get 40 minus 10 upon 4 minus 1, that is equal to 30 upon 3. So we will get answer 10 meter per second. That is the speed, and we have already calculated the speed as well by using the numerical values. So from the graphical method, by calculating the gradient, we can calculate the speed of an object. So the speed of object is constant, it is steady, it is uniform, or it is moving with the same speed. Now there are graphs related with the curves. Here the speed is 10, here the speed is 20. So it means that the speed is increasing. So if the curve is moving in upward direction as shown in the diagram, it means that the gradient will increase. So one more thing, that this line is not a straight line, this is a curved line. So it is moving with non-uniform speed and car is accelerating. So the speed of the car is increasing with passage of time. As soon as the time will pass, the car will gain more momentum, more speed. So car will accelerate. Now for this graph, it is 30 and then 20. Now what has happened to the speed? The speed decreases from 30 to 20. So this means that if the curve is like this, then this will 100% sure that the gradient will decreases. And how to calculate the gradient for a curve, we will discuss later on. So there are four type of graphs which we will deal in kinematics and in any other portion of the physics. All these will have, number one is increasing gradient. If the curve is like this, it will show the increasing gradient. If the curve is like this, it will also show the increasing gradient. If curve is like this, it is representation of decreasing gradient, and it also show the decreasing gradient. So graph number 3, that will represent this region A, let's suppose. So it will show that if the graph is like this, it will show that the gradient is increasing. So in this case, gradient is the speed, so car is accelerating. So second, if the graph is like this, the gradient is decreasing. Let's suppose it's portion B, so the speed is decreasing. Third graph, for example, an object is placed at a height of 10 meter per second. So this is the distance. So when we will drop that object, its speed increases. So this gradient also shows that the speed is increasing. So it is represented by portion C. And then the last graph, it will show that the speed is decreasing because it belongs to the left side of the circle, and it is D. So this is the basic idea related with the curve path for a graphical portion. Rather that graph belongs to distance time, it belongs to speed time, it belongs to current and voltage, or any other parameters. Now we will move to the second portion of the kinematics physics AS 9702, the speed time graph or the velocity time graph. So graph number 1, you can observe the values, all the values are 0, it means object is at rest. So you can see a very thick line on x-axis. So this is the graph for velocity time when the object is at rest. Now second graph, this is similar to the distance time graph shape. The distance time graph shape was like this, the distance and time. In this graph, that represent the object is at rest. But now if you will observe the data, what you will observe for the speed time graph, the speed is constant, the speed is steady, the speed is uniform, but there is no change in speed. The time is increasing, but the speed remains constant. It means object is moving with uniform speed. So if this situation arises with respect to velocity time graph or speed time graph, then what we will say about the motion of the object, that it is moving with the uniform speed, constant speed, steady speed, and its acceleration will certainly zero. Why acceleration will be zero? Can anyone tell? The definition which we have already done related with the acceleration was rate of change of velocity. Now there is no change in velocity. So it means that acceleration is zero, because if the velocity will not change, certainly we will get the acceleration equal to zero. Now the positive gradient and the negative gradient. So the speed is increasing uniformly. So after every 1 second, there is increase of 4 meter per second. So this will show the gradient, because velocity over time will gives us the acceleration. So acceleration is uniform. And similarly, if object is like this and object is like this, so the more steeper will be the line, the greater acceleration object will have. So similarly, you can calculate the acceleration by drawing a large triangle, then apply the formula y2 minus y1 over x2 minus x1, and then you will get the gradient. Now you can observe that the speed is decreasing. Now the value decreases uniformly. The difference between the values after every 1 second decreases by 4 meter per second. So it is uniform deceleration. So always remember, in deceleration, the velocity will definitely decrease. There is a confusion between the deceleration and decreasing acceleration. So velocity will decrease. Whenever you will observe a graph, you must see that whether the velocity is increasing or decreasing. If the velocity will decrease, then certainly it is deceleration. Now the gradient, for the deceleration, the gradient will be negative. So you can write down the coordinates and then you can calculate the value and then you will get the answer. So the answer will be in the negative value. The negative value mean acceleration is negative, mean deceleration. So for the slope going in upper direction like this, the acceleration is positive, and if the slope is going in downward direction, the acceleration is negative, and the acceleration will be uniform. Moves towards the next two graphs and probably the last portion related with the graphs. Now you can see 2, 2.5, 3, then at the end we got 4. So what is happening to the acceleration? So acceleration increases. Already we know that if the curve will move in the upper direction, again we will talk about the circle. If the circle has 4 regions, and then if we will divide it into 2 parts instead of 4 parts, then the right side of the circle will represent the increasing gradient and left side will represent the decreasing gradient. So now this curve belongs to this one region A, so the gradient will increase, and it is also evident from the values which are given in the table. So now decreasing acceleration, because the velocity, change in velocity. For example, now in this example you can see that for this, from 1 second up till 2 seconds, there is change in 5. Then 2 up till 3. Velocity is still increasing, but rate of increase of velocity is decreasing. Then 3, then 2. So we will not say that this is a deceleration. In deceleration, the velocity will decrease, and you can see the values 6, 11, 15, 18, 20. So this is the decreasing acceleration. In decreasing acceleration, the rate of increase of velocity will decrease. So I am 100% sure that now you have a very good difference between the decreasing acceleration and deceleration. So I hope you have learned a lot related with the graphical portion of this topic related with the kinematics. And if you have any other query, you can call us on my WhatsApp number, or you can write down your comments And one request that like this video and share it with your friends and other family members. Thank you very much. Stay tuned for the next video. Take care. Bye bye.